Hello, today we'll be talking about our interactive mapping application for our dam effects generator. This was created by Ryan Woods
and David Bassett.
So we decided to create a dam effects generator for those of you who don't want to buy the software of like ArcMap or other things and want to be able to create your own reservoir at will. And so what we'll be looking at today is kind of what the program does, the overall structure of it, and a little bit of the code. And so some of you may ask, why should we even build dams? Why even use dams? One of the most important things in life, I think, is having water. And out here in the West, we wouldn't be where we are if we didn't have water. And so that was kind of one of the drives to build this project, was to have a program that could figure out the size of the reservoir and how much potential water there would be. And so we'll be looking at where to put the reservoir, what volume you can potentially get, as we said, and what size the reservoir will be, and what the effects will be. And so our project, you can run the program under dam project bin debug dam project.execute. So now we'll take a look at the program. And so as you can see here, we have a map here. And so we'll just go ahead and add our DEM layer. Add DEM. We'll choose iron.bgd. And as you can see, we have this green area here, which is lower in elevation. And so that's where we're going to want to place our dam. So we'll click on add a line, click OK, and then we'll just go ahead and draw a line and double click to close it. Click OK, and you can see our line here. And so we'll just go ahead and analyze the cross section. OK, and we'll look at that here in the table. And so looking here in the table, it looks like 2650 would be a good elevation. So we'll just go ahead and type that in here. Go back to the map, and now we'll add in our grid, which is 2650, and then we'll hit calculate, and that removes everything that is 2650 or less. So we'll just pan to make sure we're in the right area. And so now we'll draw our polygon, and then you'll want to draw your polygon right on the line that you created earlier. So this way you'll actually capture the dam face. Click down here to close the polygon. Click OK. And then from there, go to Analyze, Create. And this will cut out the reservoir. And it gives you your total volume and your total area. And if you look back at the table, it puts it in here as well. And so now we'll just go ahead and go in here, turn all of these off, and then we'll change these properties just to make it look more like a reservoir. Choose blue. And then we'll choose down here just a random color with no opacity. And then as you can see, you have the reservoir. And so from there, you go ahead and click Save. And then that'll save it to your files. And if you ever have questions on anything, you can always click on the help file. And now we'll go to David, who will go over the code.
So to build this app, we used Microsoft Studio, Visual Studio, to write in the programming language C# This is built this way because of our use of dot spatial. Dot spatial is a bunch of code help that was written by people up in Utah State University. So in the code, you have to create the using. These are all the extensions and help items that have been pre-created and we use to help us build our app. In the code, we have a namespace, Dan project, and then we also have a class, which is the main form. So this is where all the code resides, and this is how it interacts with each other. So the next step was to build all of the global variables. These global variables are used throughout the different functions and allows data to be passed from one function to another. The next step is to load the extensions. What this does is allows us to use multiple extensions than just the default ones for other types of rasters and stuff like that for all the GIS. The next steps we have are to basically these are all of our buttons. So our buttons are just kind of click button events and do a lot of different stuff. For instance, a new will clear all the layers and add layers to it. Then you have an add layers. You have the save, which this is what you use at the end to save all those files. The help. When you click the help button, all the technical and the user documents will pop up to allow you to use and access those. Then of course you have zoom, pan, all those. These are all the toolbar buttons. The next toolbar button, as shown in our demo, you have digitizing a line or digitizing a polygon. What this does is just starts your ability to draw a line and create shapes. The next step, next portion of the code, this is the code to pop up the longitude and latitude. You saw the little pop-up buttons as you moved. This is the code to do that. The next, to actually draw a shape, you have to use a mouse click or a mouse double click to create them. First, the mouse click does all the different points, so it goes from point to point to point and grabs the X and Y locations for those. Then the double mouse click, again, keeps the data for the last click, but also closes it out and creates either a line or a polygon, depending on which one you chose, and then saves these files as a shape file. So saves it as a line or saves it as a polygon. The next section is the menus at the very top of our very top of that we have project layer analyze. So what these have is these pull downs, click events. So again, we have new, add layers, save, clear layers, and then here's a big one, add the DEM. And again, the DEM is a variable, so it can be used in other functions. So the next part of the code is in the analyze. So again, here in the analyze, we have dam, calculate, create cross section. So in those functions, the first one is the dam. So to create the dam height, this basically creates a DEM, creates a raster file, and then uses the data input, text height, to add into each of the levels. Uses a for loop to go row by column and keeps going through and to create the actual, and then adds it to the map. So for visibility. The next one is the calculate one. What this first does is it takes the two rasters and subtracts them to create a new raster. Then with a for loop, it goes through each raster cell and determines whether it's negative or positive. If it's negative, it throws it out. Positive, it adds it to this new raster, and then displays it on the map. Next step in the analysis is the create button. This is after you've created a polygon. So it uses the polygon, says, okay, I've got my polygon. Then it creates a data set from that polygon, then gives the projection and gets some the topology of it, and uses those in the clip function. What the clip function does is, again, uses a for loop and goes through each row and column of the raster and says, is it inside the polygon? The polygon was created here by your projections and your bounds to determine whether it was inside or out. Once those are done, we can calculate the volume and we can calculate the area. How the volume and area are created is again with a for loop. For the volume, it takes every one of the values and adds them together. So each one of those raster cells had a value in it, and it adds them all together to create the total depth of a single cell for a single cell of that. The other one, it goes through and counts every cell that does not equal 0 or has no data. So what this does basically counts every cell that has data in it. And then with your total volume area, total area here, it uses the cell height and width to calculate first the volume and then next the area. Then it creates these string values that can then be used. Here's the message box that pops up to tell you the volume and the text area, and then here's where we plug it into the table area. The last portion of this code is actually the cross-section. Again, what this does is it takes your line that you've created, divides it up into a bunch of sections, and then it looks at each vertex and finds a x and y value here, x and y value that is nearest to that vertices on the raster. And then it takes that and throws it into a data set, total length. And then here, going through, calculates slope, elevation, all that stuff. And then here, using the Z graph, again, another plugin, uses it to plug into all the data into a graph. Changes the title and the X and Y axis titles and does that. And then here this is just a load function. It takes all that data that was previously calculated and combined and throws it in and makes a pretty graph. Here you change the symbolization, symbology, the field color, the line width, outline to make it pretty. So that's the code, and that is our project. I hope you enjoyed, and thanks for watching.